Homework check. Need a little help on some of these. They're just asked in a different way. So for the first three, it says find the inverse, sketch the function, and sketch the inverse in y equals x on the same axes. So remember that a function is always reflected across the diagonal line there. So the identity function should always be a reflection. With a line, sometimes it's a little hard to tell, but with a curve you can definitely tell. So for A, x equals 2y plus 5, and you solve for y. So that's x over 2, or 1/2 x, minus 5/2, which is 2.5. So up 1 to the right 2. There's your line. And the other line is 2x plus 5. Up 2 to the right 1. So I'm not using graph paper, but I have a pretty good idea. Remember that these points always meet the line y equals x, and the two functions should intersect in that same point. Okay? One other note, I'm not going to do the rest of these problems on here, but if you want to graph this on your calculator, you need to write 3 minus 2x in your y1 divided by 4. Or rewrite this as 3/4 x minus 1/2. On these, you're just looking at the graph, and so you need to add in y equals x, and then you can just reflect across it. This one was causing some problems in class. This is the same line. You can write the equation if you want. So here, you're going to reflect. I'm going to reflect this, sort of rough, and I'm going to reflect this. I do it in pieces. There's your inverse. They're reflected across each other. On number 4, these are fine. Linear ones. This is just saying verify on number 3. So this should equal x, and this should equal x when you verify it. Number 4, though, to find the inverse, you have to do a little nifty algebra that you probably haven't done for a while. I'm going to multiply both sides by y plus 3. So I get 2y plus 1. Over here I get xy plus 3x. So we got to get y by itself, so we're going to get the y terms together. So this is 2y minus xy. I'm going to take this 1 over here, equals 3x minus 1. Then I can factor out a y, and I have 2 minus x. So y equals 3x minus 1 over 2 minus x. And then when you plug that in for f of inverse and the other way around, you should still get x. Other questions that I know people are going to struggle a little bit with. It says sketch the graph y equals x squared and reflect it in the line y equals x. Does it have an inverse? So we're just talking about a basic parabola. It's a pretty bad one. If I want to reflect it across the line y equals x, it does have an inverse, but if you extend the function, now that's not a function over here, so I can only put the inverse for that section. Okay, and that leads into this horizontal line test. A function to have an inverse function, no horizontal line can cut it more than once. So a parabola, you hit it twice with a horizontal line. So we have to limit the domain. So we essentially find half parabolas for inverses. So this would have a function, this would not have a function, this would have a function, this would not have a function. It says explain why y equals x squared minus 2x plus 5 is a function, but does not have an inverse function. Well, if you graphed it, it would hit in two places. It's the horizontal line test idea. But then when you graph y equals x squared minus 2x plus 5, when you graph it for x is greater than or equal to 1, it does have an inverse. Well, that's because, let's go ahead and graph this thing. Let's find the vertex opposite of b over 2a. So the vertex is at 1. I'm going to plug 1 back in. 1 minus 2 is negative 1, 1, 4. So 1, 2, 3, 4. And I'm going to, since this is a 1 here on this a, I'm going to go over 1, up 1. We're going to do the 1, 3, 5 rule, if you remember the 1, 3, 5 rule. Over 1, up 3. 1, 2, 3. And you don't even really need to have that to sketch it. You just need to understand that the parabola, the vertex of the parabola is at 1. That's why we have to limit the domain to x is greater than or equal to 1. It says show that the inverse of b is 1 plus the square root of x minus 4. So we're going to change this to x equals y squared minus 2y plus 5. Subtract 5. And this is a problem, again, goes back to our quadratics. It's been a while. You can solve this by completing the square. So take half of negative 2 and square it. We add that to one side, and we have to add that to the other side. So x minus 4 equals y minus 1 squared. And I'm going to take the square root of both sides. So y minus 1 equals x minus 4. And when you take the square root, it's plus or minus. So we end up with 1 plus or minus square root of x minus 4. That's our verification. We only are going to use the positive version because we can only use half of it. We could also use the negative version, but so if there's a function that doesn't pass the horizontal line test, you have to make sure that it's limited before you start, so that it does pass the horizontal line test. So like looking at these pictures, we would have to limit the domain to this, or to a section here, or to a section here to be able to get an inverse. Okay, so finish the rest of the problems. We'll collect that on Monday.